So there's three ways to write a vector. The first way is component form, the pointy form with little points. Y'all know that. And then the next one is going to be linear combination form. And you know that's the stuff that has the letters I and the letter J. And then, that's okay. All right, here's our brand new form. So the brand new form that we're going to write on this last line, your buddies sine and cosine are coming back. So it is r cosine theta sine r sine theta. So that's going to be another way. And let me just get caught up. So you guys should have wrote A and B here. And then this is AI plus B. Okay, so let's kind of get used to this last form we're talking about. Find the magnitude and the direction angle of the vector. Well, the nice thing about sine and cosine is the magnitude is the number in front. So you don't have to add things together, square root things together. The magnitude is just the number that's in front. So the magnitude for vector V is just 4. And then the direction angle is the actual angle. See how there's 120 degrees there? So we don't have to find the angle. So that's nice. It serves a purpose. It's easy to find some stuff. So over here for problem 2, the magnitude is the number in front. So the magnitude is root 2 over 2. And then our angle, let's go ahead and write 3 pi over 4 in degrees. Do y'all remember that? Second quadrant. 100 and... What's 90 plus 45? Yeah, that's it. 135. All right, and we're going to write it in component form. So easy, y'all. All right, look, let's recopy this magnitude on the outside of the parentheses. Let's draw some parentheses. All we have to do is write the cosine and the sine values for 3 pi over 4. Remember, anything in 4 is root 2 over 2. But remember, we just talked about it being in quadrant 2. Yeah, the x is negative. And we literally just distribute. So root 2 times root 2 is 2. 2 times 2 is 4. That's going to be the same thing but positive. So vector V in component form, which is the most common form, is going to be negative 1/2 and positive 1/2. All right, problem 4. Let me get this bar out of the way right here. All right. So for problem 4, we're going to find the exact component form and the linear combination form of V, given the magnitude and the direction. We're actually going to alter one of these problems, guys, because I want to show you what happens when it's not on the unit circle. So will you please write 52 degrees for problem 6? Cross out 315 and write 52 degrees. All right, so here we go. We're going to write the exact forms. So we're going to recopy the 14 on the outside of the parentheses and just put the cosine and the sine value for 30 degrees. And remember, 30 degrees is pi over 6. So remember, pi over 6 is going to be root 3 over 2 and then 1/2. We're just going to distribute. So when we distribute, we're going to do 14 divided by 2. And the instruction said to have exact form. So vector V in exact form is going to be 7 square root 3, comma 7. Let's do problem 5. So it's going to be 5 times a couple of numbers in here. So that's 4 pi over 3. What quadrant's 4 pi over 3? Yeah, it's thirds. So they're both negative. So it's going to be negative 1/2, negative root 3 over 2. And let's leave them as improper fractions. So this vector is going to have a component form of negative 5/2, comma, negative 5 root 3 over 2. Okay, believe it or not, when it's not on the unit circle, it's actually a lot easier because the calculator does all the work. So when it is not on the unit circle, we cannot do exact form. So guys, all you're going to do is you're going to turn on that pretty pink calculator and you are going to type in the magnitude. So let's hit 6 and then type in cosine 52. Cosine 52 and hit enter. And then we're going to round 2 places behind the decimal. So this vector has an A component of 3.69. And look, I'm going to show y'all how I cheat. If y'all already knew this, that's cool, but watch. I'm going to hit arrow up, and I'm going to put my cursor on cosine and replace it with sine, and hit enter. And then there's the sine value. So that's going to be 4.73. So when it's not on the unit circle, not a big deal, but we are going to round. If it is on the unit circle, it does need to be an exact form. That's how this stuff works. All right, so that's what we're doing with sine and cosine today. Any questions? All right. The back is word problems. So you're going to have word problems with vectors, which are pretty applicable. Okay, here we go. Our word problems. If I can turn the page. There we go. So all of these word problems are super easy. You guys have worked way harder word problems than this. But some of them have a little more work than others. This is like a level 3 workload, just letting you know. This is like a level 2 workload. 9 and 10 are really level 0, but we're going to say level 1. So remember, that's not level of difficulty, that's just like steps. So once we get past 8, the rest is going to be super quick. All right, let's back up and talk about 7. So 2 forces with magnitudes of 100 newtons and 500 newtons act on an object. The angle between the 2 forces is 30 degrees, with the 100 force being pulled along the positive x-axis. Find the direction and the magnitude of the resultant of those forces. Y'all, resultant is a fancy word for adding. So anytime you see this, you're just adding the vectors, and you added vectors in 8.1. So that's nothing new to you either. So this is just adding. All right, so here's what's going on. There's some object right here, and it has 2 forces pulling on it. One of them is going along the positive direction of the x-axis. We're going to call this vector A. And vector A has the magnitude of 100 newtons. But remember, there was another one of 500 newtons, and it was creating a 30-degree angle. So we'll call this vector B, and remember, this one has a magnitude of 500. Okay. So since we need to find the resultant, we're going to add them, and the only way you can add them is if they are in component form. So the first thing we're going to do is we're going to write this form. And then we're going to put it in component form. All right, so let me start with vector A. So vector A has a magnitude of 100. It's going to be 100 times cosine and 100 times sine. All right, so it's being pulled straight flat on the x-axis. If it's flat on the x-axis, how many degrees does it have? 0. Think about the unit circle. What's cosine and sine for 0 degrees? 1, 0. That's right. That's what goes in here. 1, 0. And then when we multiply that out, we're going to turn it into pointy form, component form. So vector A is going to be 100, 0. All right, now let's work on vector B. This is going to be 500 times some stuff. Y'all should know this. 30 degrees is pi over 6. What goes here? Now listen, since we're dealing with word problems, and if you want to write this up here, that's fine. Word problems are always rounded. So we're not going to have square roots in our answer. So guys, y'all, what's 500 divided by 2? Right. So on your calculator, do 250 times root 3. On your calculator, do 250 times root 3. And we are going to round 2 places behind a decimal. I'm going to put 250 here because I know that's just 500 divided by 2. What do y'all get, like 433-ish? Okay, 433.01. Thank you. All right, time to add them up because that's going to be the resultant. Now, when we add them up, we're going to call this vector R, and that's pretty common for when you add up vectors. You might see something titled vector R after something's added again. You might see that. All right, so vector R is going to be 433.01 plus 100, so 533.01. 0 plus 250 is 250. We did all that work. Now we can finally start answering the questions. We need to find the direction, which is the angle. So we're going to need the angle for vector R. And we're going to need the magnitude for vector R. And you guys did that yesterday. Okay, thank you. Don't forget your degree symbol. And then this is 588 what? Thank you. And let's go ahead and say newtons because it's a word problem. Any questions? Everybody good on the 25.13 and the 588.73?
Whenever it's big numbers like that, you want us to read it. Like the magnitude. Like whenever it's a really big number like that. How it was, at least.
Where's 9 and 2? What are you talking about?
The magnitude.
Yeah, magnitude's always rooted
Okay.
when it's in component form. If it's in this form, you don't root it. Okay. Okay, so there you go. That's going to be the answer for that. Now let's look at the next problem. All right, for the next problem, you're going to have 3 forces with magnitudes of 75, 100, and 125 pounds. They're going to act on an object at angles of 30, 45, and 120 respectively with the positive x-axis. Find the direction and the magnitude of the resultant. There's that word resultant. We know we're adding these together again. So, did it say any of these are pulled along the x-axis? That says the word with. That just means that's where it starts. So that's not the same as being pulled along the positive x-axis. So let's draw a little setup here. Here's my x-axis. Here's my y-axis. All right, so you got a 30-degree. I'm going to call this vector A, and vector A had that small magnitude of 75. Okay, and then you have a 45-degree angle, okay. And then remember, let's just make this B. We'll just go in alpha order. So vector B is going to have a magnitude of 100. Don't forget vector C is going to be over here because it has 120 degrees. So it's on this side. So this whole angle is 120, and we'll call this vector C, and it also had the largest magnitude of 125. There is nothing different from here than problem 7. The process is the same. You're just going to add up 3 things instead of 2 things. So here we go. Remember, A has 75. I'm just going to make my setup here. We're going to convert from cosine sine to component form. Okay, back to that little baby 30-degree angle. So that's pi over 6. 45 degrees is always easy to remember. Remember, your 120 is 2 pi over 60. 2 pi over 60 degrees. 2 pi over 3. This is 2 pi over 3. Two pi over 3. All right, so for component form, again, guys, I don't really have these memorized. I know 75 is 34.5. But can you guys please do 34.5 times root 3 and let me know what you get? Oh, oops, it is. Thank you. That is 37. It is, it is, it is. Okay, my bad. What's 37.5 times root 3? 67.95. All right. So these second ones right here, are they 70 point something? Thank you. All right. And then I want to say I know 125 cut in half, but I don't know. I messed up the first one. Is it 62.5? All right. So I got that one right. What's 62.5 times root 3? 108.25. Thank you so much. All right. Have you guys added them up? I bet you're way ahead of me. I bet you already have vector R in component form. What's the first number? 73 point something maybe?
73.16.
Thank you. And then maybe a 216, 215.93. Thank you so much. Now remember, once we get down to problems 9 and 10, it's going to go a lot faster. And we're almost done with this. You just need to find the direction of the angle and the magnitude. I have a calculator right here. No, I had it. Okay, so second tangent, 215.93 divided by that first number. So we're going to get 71.29 degrees. Don't forget your degree symbol. And then some of y'all are calculator savvy where you can enter this all in at once. If you don't think you can, don't do it, because one little mistake will get it wrong. I'm talking about finding the magnitude. Okay, so we should have got, well, that's going to just round to 228 even. Well, it's 0.99, but I'm leaving it. Did y'all get close to 228? That's what matters. Did everybody get that? In the ballpark of 228. Okay. Again, guys, you made it past the hump. There's like 2 more minutes left of the lesson. We're almost done. Okay, here we go. All right. Oh, you know what? I do want to write pounds here. See if you can squeeze in pounds next to your answer for the magnitude. All right, here we go. A ball is hit with an initial velocity of 130 feet per second at an angle of elevation of 49 degrees with the horizontal. Sketch a picture and find the vertical and the horizontal components. That is key word for component form. Like, there's no second guessing what that means. All right, here's the horizontal. Somebody hit a ball and it ends up going like that, and it makes an angle of 49 degrees. Now remember, that's not on the unit circle, so make the calculator do all the work. You're going to type in 130 cosine 49, and then 130 sine 49, and that's going to be the answer. Now look, when it asks you to identify the components, you guys can't just write this in component form. You actually have to identify, so be careful on word problems. So we're going to say we're going to have to label the horizontal component. Look, I got 85 point something and 98 point something. Did you get that too?
Yes.
Thank you. You got to make sure you get it today because I can't help you later. So, those are the components for that.